Meet NGTS-1b, a monstrous planet that should not exist. Welcome to Mysterious World YouTube channel. Subscribe and share for more update. A giant planet, so disproportionate that it should not exist according to the theory of planet formation, has been discovered around a small distant star. The new research detailing its discovery was presented for publishing in the monthly notices of the Royal Astronomical Society. The existence of the monster planet, NGTS-1b, defies the theories of planetary formation that affirm that a planet of this size could not be formed around such a small star. According to these theories, small stars can easily form rocky planets but do not accumulate enough material to produce planets the size of Jupiter. However, NGTS-1b is a gas giant. Due to its size and temperature, the planet is known as a hot Jupiter, a class of planets that are at least as large as our own Jupiter, but with about 20% less mass. However, unlike Jupiter, NGTS-1b is very close to its star, barely 3% of the distance between Earth and the Sun, and completes one orbit every 2.6 days, which means that 1 year in NGTS-1b lasts 2.5 years in Earth's days. In contrast, the host star is small, with a radius and a mass half that of our Sun. Professor Peter Wheatley, of the University of Warwick, detailed in a statement the complications that this introduced to astronomy. Despite being a monster planet, NGTS-1b was difficult to find because its parent star is small and faint. He went on to explain that small stars are actually the most common in the universe, so it is possible that there are many of these giant planets waiting to found. NGTS-1b is the first planet to be detected by the Next Generation Transit Survey, or NGTS, that uses a series of 12 telescopes to explore the sky. The researchers made the discovery by continuously monitoring patches of the night sky for months, and detecting the red light of the star with innovative red-sensitive cameras. They noticed dips in the light of the star every 2.6 days, which implies that a planet was in orbit and periodically blocked the light from the star. Using this data, they tracked the planet's orbit and calculated the size, position, and mass by measuring the radial velocity of the star. In fact, this method, which measures how much the stars wobble due to the gravitational pull of the planet, was the best way to measure the size of NGTS-1b. Daniel Bayliss, lead author of the study, from the University of Warwick, said, "The discovery of NGTS-1b was a complete surprise to us. Such massive planets were not thought to exist around such small stars. This is the first exoplanet we have found with our new NGTS facility, and we are already challenging the received wisdom of how planets form. Our challenge is to now find out how common these types of planets are in the galaxy, and with the new NGTS facility we are well placed to do just that.